Hey campers, welcome back. Hope you had a good time down at the lake. Hope you didn't go swimming too close to eating lunch. Welcome to Saturday afternoon episode of Old Man and the C Sharp. This episode we're going to cover logic and data types. I just had to check my notes there, don't mind me. Start a timer so in case things take a little bit too long. Hopefully they won't take too long at all. All right, so let's get down to business. Today or this hour, we're gonna cover, first I'm gonna cover data types, which is just all the different ways that you can manipulate different types of data in C Sharp and in Unity. And then we're gonna go into logic, which is kind of what we can do with those data types. And then at the end of this episode, maybe the last 10-20 minutes or so, we'll make a small sample program that just plays with the output of the console without actually doing anything in Unity. That'll be next episode. Okay, so why don't we get started with data types? So you remember our friend Bool from earlier this morning? Bool is just a true false thing that we can address in various different ways um, to get the result back that we want. And we could just define it as true or false, or we can actually set this to be another logical value, which we'll get to in the next section. But what do we have to play with other than bools? Well, there's only a handful of types that I'm going to cover in this. There's a lot of different primitive data types that we can fool around with in C Sharp, but for the purposes of Unity, you're probably going to focus on just a few, and those include um, uh, oh, I almost wrote boobs. Oh no, buckaroo. There we go. Okay, so a bool is just a true false. A string is encapsulated in quotes always, and it'll nicely highlight it for you if you do it correctly. Um, Strings are really good for just reporting things back or recording things like that. You can't usually do a whole lot of logic with strings in Unity. It's kind of just not normally done, but not impossible either. So you can get creative there. But when we're getting to numbers, let's start with integers. Integers you denote by writing int in front. So in this case, I've named a variable x because, everyone does, math with, x plus y equals z, right? So integers can be any whole number between or that's positive or negative. There's a certain max range. It's a big number. So if you're playing with crazy numbers, maybe you might want to worry about that, but later. The problem with integers, though, for most of Unity's work is Unity plays a lot with 3D or even 2D space, and that's measured with fractional numbers. And if we can see that just by opening up our copy of Unity again, and we can see like here's our cube floating in the sky, and its position is a fraction, right? And we can move them around, no problem. But we don't want to only deal with whole numbers when we're dealing with positions, because in Unity a value of 1 equals 1 meter. So if you can only use whole numbers, you'll get values like 0, which is about there, and if I type 1, it just jumps over 2, 3, 2, 1, 0. So you see it hops around. If you want smooth motion like that, you need the fractions. So if we want to do fractions in Unity, the way we deal with fractional numbers is with float, which we'll use a lot of. Now, floats can be positive or negative, and floats are named after ice cream floats because the original programmers really liked desserts. No, I'm just joking. It stands for floating point number. Um, there's It's out of scope for this video. There's a very interesting, long-winded, sciencey, mathy explanation for why computers struggle with floating point operations, uh, which is to say big, long decimally numbers versus just whole numbers. So you can use whole numbers with very high precision, and you can use floats for lower precision numbers that can be of a fraction. And by lower number, I mean like you can make a number like that, and you can make a number like like that, and both of those are fine. You'll still see things, and I mean these numbers are so big and so small, you probably won't notice any major differences between them. But this number might be identical to that number, right? Like changing that 1 to a 2, like there might be a little bit of error in this number. And, this is, if 1 is a meter, then this is like a micron, right? So it doesn't matter for most of our purposes. So don't worry about it. If you're working on a universe simulator or something, or a little subatomic particle simulator, maybe you have something extra to think about, but don't worry about it. The other interesting thing is that computer scientists have a very good reason for enforcing this little f on the end of the number. That reason is boring and doesn't really affect you and me, so let's not get into it. Just know that anytime you're dealing with floats, you have to put a little f after the number, just to be safe. If you don't put the F and it's a whole number, it's fine. It knows what you're talking about. But you try to do a 1.1 in there, and it's going to be all like, whoa, red squiggly lines. What are you doing? I don't know what this is. What is this sequence of digits? What could it possibly be? And then you put F, and it's like, it's a float. So, yeah, that's the kind of the primitive data types that we're going to be dealing with here. There's other things. There's like arrays and uints and oh, blah, 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 blah. If you're thinking to yourself, oh man, I wish I could represent an idea with something not these, it probably exists. So we'll get into that in a little bit. Um, Two things I will mention real quick, because we'll probably use a lot of them, are two things that are not primitive data types, but they might as well be when we're thinking about Unity. One is color. Uh, there we go. So color is very handy, and we're going to be using a lot of color. Um, Color is built into Unity, so this is a Unity feature, not a C# feature. Programmers decide color doesn't exist. That's a Unity +1. That's what you get for that free download. The added value of color. And the other thing is Vector 3. Ooh. And that's kind of how you would declare a Vector 3. So in maths terms, if you're a maths pro and you're kind of new to programming, this should come easy peasy. But if you're not a maths pro, a vector is just a, well, what is a vector? The vector, vector, vector. Oh, look at these vectors. There. So now that we're all caught up to speed with what a vector is, um, basically, a vector can be thought of as a direction or a position or a 3D coordinate or any number of things. But basically, under the hood, a vector 3 is just float x, float y, whoa, 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 whoa. Come on, float z. That's it. right? So a vector 3 is just 3 different floats kind of bound together. And actually, if I pop into Unity again real quick, see this rotation value that has X, Y, Z? They don't track X separately and Y separately and Z separately. And same for rotation and scale. This is just a vector 3, vector 3, vector 3, and then they just display it nice and neat on the screen for you. So that comes up quite a bit because Unity's 3D vector 3s are 3D. I should probably do a whole tutorial just on vector 3s and playing around with them, but we're going to play with vector 3s a lot. They can mean anything. It doesn't just mean X, Y, Z coordinate. It could mean like a speed. Like if you think about how you'd uh, like do a direction or like a wind direction, right? Because if the wind um, in 2D space, there is like a concept of a vector 2, and there's also a vector 4, but vector 2 would have 2 components, right? And you could say component 1 is the wind direction, and component 2 is the wind speed. So the way you might make that is like, a new vector 2, or sorry, vector 2 equals wind equals new. Then you can say wind, so we can use the X component to be the wind direction, and we could say maybe the wind's going at 180 degrees, and maybe it's going at 400 miles an hour. Now we have a wind, like we don't have to track wind speed and wind direction separately as different variables. Now we have it all in one tight package. The reason why you might want to bind them together like that is because you can do fancy maths that I won't get into here to rotate that. So it's really easy to just rotate things around, swing things around, translate things, make it bigger, small, lots of cool tricks you can do with vector 3s. So, and vector 2s. But we're just going to see it come up a little bit more and more and more and more. Other keywords, so like color comes with a bunch of built-in basic colors. Again, you could just hit period to see a little pop-up, and it'll tell you all these little things like, well, white, red, green, black, blue, whatever, clear. There's a fun color that you never use. So you just pick whatever you want. Likewise, you can say, oh, what kind of vector 3s are there? And there's like 0, 1, a bunch of fancy things. 0's nice to start with because it just makes the X, Y, and Z components all zeros, and then you can do whatever you want with them after that. But I'll get more into those later. For now, just know that these are kind of the fundamental tools that you have to work with. Anything, when you're doing the make a sandwich routine, anytime you're like, oh, take 2 slices of bread, just think to yourself, what represents that 2? Now, you could write a string that says 2. You could write it as a float, as a fraction, 2.0f. But it probably makes the most sense for that to be an integer, right? Because it's just a whole number. You're never going to subdivide it. Unless you take 1 loaf of bread, or 1 slice of bread, and you cut it in half later, well, now all of a sudden you need to use the float version of that because you can't cut this 1 slice in half. And in games, precision's nice. Sticking to ints is fine if you need to, but if you stick with floats just about everywhere, it'll work in most cases, and it gives you the most flexibility. If you never divide it in 2, that's fine. If you want to divide it in 2, you can without changing anything. So I highly recommend sticking to floats. Just stick to floats. Now let's talk about scope a little bit. I've been meaning to tell you about your breath. Another product callback. No, I'm just joking. I'm talking about variable scope. So you notice all of these variables. I think I talked about this morning as well, but just a quick refresher. Here in the start function, which is called once by Unity once the program starts, we're declaring all these cool variable names that are super hip and awesome. But if later on in the update loop we want to check on any of them, like, hey, if x, if, come on, autocomplete, let me type what I want to type. So now I'm saying if x is 1, it's like, what do you mean x? And you hover over it, it's like, x doesn't exist in this context. What are you talking about? That's because all of these things, because they were defined in start, only start knows they exist. And this is kind of denoted by these braces here, right? Anything inside the braces stays in the braces. You can't break out of those borders. And this is a good thing because you don't want like one variable x to be accessible everywhere in your code base, right? Like you don't want it to be like you want to constrain it as much as possible so that other things don't muck with your data. So this might be good if all we're doing is dealing with stuff in start, but we want to reuse this variable here in the update loop. So there is a thing we can do, which is we could just move it up here. I'm going to say bool is invincible. Now I can say here if is invincible, and it's fine with that. So anything outside of the braces can be accessed, and we can use that same variable in this other function as well, and it won't complain about that either. So we have access to it in all spots, which is really nice. So that's called the concept of scope or context, is what we call it. So this is just kind of management. Now, if you want to be messy and sloppy, that's fine. You might cause yourself some problems down the road, but I just cut and pasted all of my different data types outside of scope here. So now all of my code can see all of these numbers or all these values. All right, so that's fine. That's cool. But let's learn a new trick. Let's learn a new trick. I'm going to save this, and I'm going to swap over to Unity real quick, and I'm going to show you. Here's my blank game object that I've put my hello ants script onto. So you notice other scripts and things, like if I click on this other cube, see there's all these things down here on the side in the inspector, all these different values you can play with. And we look at our little script and it's got nothing. It's totally blank. How do we make it more interactive there in Unity? Well, we do that with kind of permissions. Permissions we've seen secretly this whole time, and I just haven't mentioned it. Here's the first one, right here, the word public in the class declaration. So this is saying that hello ants is a public property. Now the opposite of public is private. There are a few other permission types, but no, don't worry about them. And you'll see that this will not work. It's just going to error. Can't run. Unity's going to complain. This is because if we make the class private, I mean, there's nothing wrong with that, but it means that nothing can access it, right? It's private. Everything will stay internal to it. It's going to be just its own thing, doing its own thing. Nothing can talk to it, right? So it makes sense that we're going to want to talk to this class. At least we're going to want to let Unity talk to this class so we can actually work with it. But you notice that this start function and this update function, this is just shorthand. The permission has been left off of it. Here's my function. I didn't type a permission on here. And if you don't write a permission, it defaults as if you typed private. Now, If you have a public function, what that means is that this function can be called from a different file. So later on, if we write another class like hello sloths or something, it will be able to call into hello ants and call this function as well. But, oops, I'm hitting all the wrong buttons. But if we want this function only to be used by hello ants, we call it private, or we don't write anything at all, which just defaults to private, which is kind of what it did for a start and update down here, right? So that's kind of useful if we're going to get fancy with our code. But where does this come into play with our data types? Well, same thing goes for these. This Boolean, because nothing was declared, no permission was declared, it's considered private. So only this class can ever refer to this data, to this variable. But we can throw public in front of that. And as soon as we do, if you hit save and you pop back into Unity, look at that right there. It even put a space in. It auto-detected the naming convention. And now we got a little checkbox, right? So that's how, just by simply saying something's public, we're able to kind of allow access to it in other places, right? Okay, so let's get rid of all this other junk for now. And let's move on to logic. So now we know the basic building blocks of what we can use. And now let's figure out how to stick them all together. So in the last, earlier this morning, we were taking a look at simple if statements. Now, if statements always take one argument, right? Which is just a true or false. You can write if true, that's perfectly reasonable. You write if false, that's perfectly reasonable. You say if 1 plus 2 equals 3, perfectly reasonable. Anything that you type in between those parentheses can be boiled down to either a true or a false statement, no matter how complex it is. If it could just be answered with yes or no, it can go in an if statement. And that's where we can get real fancy, because we can say public int x equals 1, public int y equals, you know what, I'm not going to put the equals in there. I'll show you why in a second. Because now I can say something like that. Heck, why not all three? X, Y, Z, if X plus Y equals Z. Now we have, so before when we were just saying if 1 plus 1 equals 2, that will always be true, so that code will always run, so you might as well have not written the if statement at all. But if you start swapping in variables into those places, then you could start having a dynamic piece of software that reacts to different things. I'll get over what that means, that crazy thing means in just a second here. But because I made X, Y, and Z all, forgot to save, because I made X, Y, and Z all public. Now, if you pop into Unity, you can see X, Y, and Z are all public. And we could set these to, 1, 1, 2. And now if that's 1, 1, 2, X plus Y equals 2. This will always be true until we change the setting over here, right? Until we change the value on the game object. So yeah, that's the very first baby step into logic. So what are the different logic operators that we can play with? Well, we have a setter, which is equals. We have the what are they called? Pretend those don't exist. And then we have the comparison items, which are I think that's all of them off the top of my head. And you know what, there's more. So these are kind of the basic fundamental building blocks of C#, the language, or actually almost every programming language. You'll get really used to all of these symbols and what each of them mean. Most of them are kind of obvious and plain and simple. So we know that x is, what did we set it to? X is 1, right? So you could say x equals x plus 1. So that just makes, because a single equal sign is a setter, x becomes x plus 1. So x will become 2, right? In fact, just to make that for sure true, that will override the value that we set in Unity. So x equals 1, x equals x plus 1, x equals 2. We can also say x plus plus. That is just a shorthand that we've come up with as programmers because we use x equals x plus so frequently that we just have x plus plus increments it by 1. We can also say x plus equals 1, or x plus equals 5. So this x now equals 3 because we've been incrementing it, and now x equals 8. Does that make sense? So x is 1, x equals x plus 1, x increments by 1, always by 1. And we can say plus equals 5 to say we're adding to it. And similarly, we could say x minus equals 5 to get us back to 3, right? So these are all like just really basic kind of arithmetic-y operators that we can do on things. So that covers the bonus setters area. I'll try not to use them for the rest of the video though. Because they're bonus and you don't need to do them, they're just shorthand. It might just add confusion. So I'm going to remove them. I'm going to leave up these ones though, because they're dangerous and you don't have the access level privileges to know why they're so scary and why they're so similar to the good ones. So let's take a look at is invincible. So I'm going to say player has health, and the player has donuts, and the player has tickets for the Ferris wheel. And you know what? I'm going to make this one a float. Yeah, maybe we'll break those donuts in half someday, but those Ferris wheel tickets, they'll always be. Just out of curiosity, if we just save, pop back over to Unity. Oh, what did I do? It's saying it's unhappy. Oh, because I still have these old ifs in here. Save. It's okay, Unity. See, now we have health, which we can make 11.5, and we have donuts, which we can have 2.2, and we have Ferris wheels, and if you try to type 2.9, like it doesn't even let me type the decimal character. Just because it's an integer, you can't make it a fraction. It tries to keep you safe, tries to stop you from making a mistake. Okay, so I'm trying to make a little game, and I want to make sure that my if statements are much more interesting than just trues and falses and things. Well, they'll always be trues and falses, but because it's easy enough to say, whoops, I said I wouldn't. I mean, that's easy enough to understand, right? If you're invincible, you earn yourself a bonus donut. It makes sense to me, right? But what if we want to check multiple things at once? You can get fancy and you can say if invincible and Ferris wheel tickets. There. That makes sense, right? Now, just like in math, like if you're doing your algebra or whatever, and you're like x equals a plus b divided by 2 times c minus 1 times 3, and stuff like that. Um, and you do the order of operations with the braces first and all that kind of stuff, right? But all of this still resolves down to one number, right? Same thing for anything in the if statement. So this has to everything in the parentheses has to resolve to either true or false. Nothing in between, no ambiguity, must equal, right? So the and operator just means that both things on either side of it have to be true. So if you're invincible and your number of Ferris wheel tickets equals 2, then you lose a donut. All right. That makes sense? Now, you can like put parentheses around this if it helps you make sense of it. It doesn't change the output, doesn't change the feedback at all. It's just fine. But you can get fancy, and you can say if the number and Ferris wheel tickets equals 2, or so that's the or symbol, the double pipe, which is shift backspace, or health is greater than or equal to 100, right? And now we're getting longer than our line, and it becomes a little harder to understand, but it still boils down to just true or false. Just like in math, do the parentheses first. So let's ignore this one. Let's do the inner parentheses, which is this one. Or means one side or the other must be true, which makes sense, just like it does in English, right? So either if your Ferris wheel tickets is 2, or if your health is greater than or equal to 100, right? Is that true or false? And this will boil down to is invincible. I'm not even going to correct my typo. Let's say it's true. Let's say you have 2 Ferris wheel tickets. Then this whole block is going to be true. Then it compares the outer parentheses, which is, if is invincible and true. So if is invincible is true. So if true and true, then it works, right? But I understand how it can be confusing, and this seems complex, and especially if you haven't brushed up in your algebra in a long time, dealing with things in parentheses and stuff can be confusing. So here's a pro tip. Try to break down your complex statements into different lines of code and encapsulate them in variables that make a lot of sense to you. So for example, we can say, we can make a new Boolean, which is either true or false, and we're going to name it has a pair of tickets. And we can say this equals Ferris wheel tickets is greater than or equal to 2, right? So now has a pair of tickets is going to be true or false depending on this output. And that allows us to take this bit of code here and replace it with that Boolean. And now this just became a little bit more English readable. Now let's do the same thing for the health, right? Bool has superhuman health. So I'm saying, what does it mean to have superhuman health, right? Making that sandwich. Superhuman health means your health is greater than or equal to 100. Now I can replace this with has superhuman health. And now nothing's changed. The logic is the same. We're just making it step by step more and more human readable, right? Now we can even go a step further. So we want to compare the two of these, right? We have the or here, has a pair of tickets and has superhuman health. What what condition is that describing? Like, try to be descriptive in your thoughts. And if you come up with good labels, usually the definitions nicely follow. So I want to say, what does this mean? Uh, you are super person on a date equals has a pair of tickets. I'm going to change it from an or to an and. Okay, so if you have superhuman health and you have a pair of tickets, I'm going to assume you're on a date, right? Now, I made a mistake. It pointed it out for me with a nice red underline. I used equals equals, which is a comparison item. It's not the setter. It's smart enough. It caught it. Let me know I did a screw up. That's okay. Just delete that extra equals. Done. So now I know if you are a super person on a date. That means we can now delete all this and say you are a super person on a date. And now we can boil it down even one more. If you are invincible and you're a super person on a date, who's invincible? Is that Superman's not quite invincible, right? Doctor Who's invincible, right? Can just regenerate? Okay, so you are Doctor Who. So the state of, wait, you are Doctor Who on a date. So to be Doctor Who on a date, you have to be a super person on a date, and you have to be invincible, which is different from just having a lot of health, right? And now we know we can replace this because this is just the same logic, right? So I didn't change anything there. Like, the logic still flows almost the same as when we first started. All I did is I just broke down the logic into its discrete chunks so that the if statement that we are actually focusing on, the transition into subtracting your number of donuts, is as understandable to ourselves down the road in the future and to other people. And you can really easily tune and tweak all these different numbers now, and you can change the conditions. Like, maybe superhuman health is actually 90 health, whatever that means. Or maybe Doctor Who is only into triplet. There's all sorts of different tunings that you can do. Now, that makes a lot more sense than digging into the old line I had with the nested parentheses on the if statement, right? It all boils down to the same thing, but oftentimes when you're looking at something that's very complicated and hard to read, it's just because the person hasn't broken the data down into individual logic bools, right? So if you're just learning, try to define all of your if statements by a single bool just to help train your brain into thinking about everything in black and white. There is no gradient. You must pick a side, one or the other, black or white, right? All right. So we could do, so I've demonstrated in this greater than and equal to. I mean, obviously you can do less than or equal to. I haven't done the exclamation mark yet, though, which is not. So exclamation mark is not. And I could say, I mean, this is going to be an obvious one, is vincible. Yeah, that's too confusing. Is hurtable equals. So is hurtable is now defined as the inverse of is invincible. Is hurtable is not invincible. But that's not the whole story, right? Like, we can modify this a little bit. We could say you're not invincible and your health is greater than 0, right? You can't hurt someone whose health is already at 0, right? Unless your game allows negative health or something, right? But so now is hurtable is now defined as not invincible and health is greater than 0. If you are not invincible, or if you are invincible, or if your health is already at 0, then is hurtable will be wrong or false. And then we can define a separate one. Should take away donut is you're a Doctor Who on a date, and nothing hurts the doctor more than taking away a donut. There we go. So now, if you should take away a donut, take away a donut. Nothing simpler than that, right? And if you ever think to yourself, well, what should take away a donut? Well, this defines it, right? And well, what defines this? Like, what defines this? This does. And what defines this? This does, right? So that's kind of all of programming in a nutshell, right there. It's just taking donuts away from supernatural characters. Uh, you define things in singular statements, and then you just kind of follow that chain of logic until you come to a decision point. And the decision point is, do you take away the donut? If you don't take away the donut, I guess you get a bonus donut or whatever you want. Maybe we don't touch your donuts. Maybe just take your tickets, but it doesn't matter. So that's been kind of a nice introduction to all the varieties of different logics that you could do. This not invincible, we could also actually, that's kind of a shorthand as well. I could have said is invincible. That's the same thing, right? Not invincible or is invincible equals false. Those are two ways of saying the same thing. There's a lot of these in programming. There's a lot of different ways to say the same thing in different styles to maybe change things up a bit or make things more clear or more readable. So if the exclamation mark is something that is a little confusing or something like that, you can use false. Or the last one that I didn't do, I left it out by mistake, is not equal. So you could say is invincible does not equal true. So not equal is the invert of equal, right? So I think all of this is pretty, like, you have some basic math remembering from high school. Um, it should read fairly well. I mean, if you just take a look at this for the first time, just at a glance, this may seem overwhelming, right? But when we're going through it step by step, every step of the way, it kind of made sense. And it's just learning how to read it, learning how to string it together. That's what gets you moving along. And there's ways to complexify it. There's ways to make it harder to understand and more dense. There's ways to make you faster. There's ways to make your typing faster and more efficient. You can get into fancy things. That's the kind of stuff that makes code look hard and can scare you away. But just know, if you're ever typing something and you type the same thing over and over and over again, you're like, oh, there should be a faster way to do this. There probably is a faster way to do this. So, yeah. One quick thing. Oh, no, you know what? I think I'm going to jump to example time. So we've just been kind of like, none of this is throwing errors. This is fine. Unity's not complaining. We could run this, but it wouldn't do anything because we're not outputting anything. So I think what I'm going to do, these cursed unmentionables, if you never use these, you're good. That's it. There's never a reason to use them. If you use them, that's on you. If you ever type a single one of these characters in your code, they're going to come for you. So just use these doubles all the time. Just always these doubles, ands, and ors. Don't worry about it. It's fine. All right. I'm going to make a thing. I'm going to make a quick little game in Unity that just uses the editor console output to have a little bit of fun, right? Using all the lessons we've learned so far without getting too complicated. Your homework is to watch what I do, kind of understand the logic flow of things and how I'm getting output, and try to go and write it again yourself without causing errors or without, setting your computer on fire or anything, right? Because then you'll know that you're getting syntax down. You'll probably make dumb mistakes. You're probably going to forget your semicolons. I still do all the time, but at least you can get started trying to make some things, because now you have enough knowledge. Now you've now do have enough knowledge in you after watching just these two videos, how to make any game. It just all gets more nuanced and faster from here, right? So let's take a look at a really basic, simple output. And then for the evening class later today, we'll do a 3D thing. Okay, so I want to make a thing where, let's do this incrementally. Let's just do a little bit incrementally. Let's say you have a score, and I'm not even going to use the start function because I want it to be a game. I want it to be interactive. I'm only going to use Unity's update loop, which remember fires every frame, right? And in the update loop, I'm going to check to see if the key you pressed is spacebar. So does that make sense? Inputs a Unity command, get key down is Unity command. I kind of went over these. Spacebar is the key that I want to detect. Now, if I'm following the lesson to make this more readable, right, was key pressed equals key code space, right, was key pressed, there we go, right? So I didn't change anything. It's the same thing. It just reads easier now. And if you want to get super fancy, you can make a function, and this function returns a bool, which we discussed in the morning's video, right? We just say return this value. And now we have a nice squared away function call that we can call from anywhere. Functions like having little parentheses at the end for reasons we'll get to another day. Oops, oops, oops. There we go. So now I have a block of code where I'm writing a little note to myself. Anything here in this block of code, I know that spacebar is pressed, right? Done. So now I have a nice logical entry point, reads really easy, reads really clean and nice. Now I just want to do something like score, or I could have said score plus plus, but I'm not gonna because it reads easier this way for new folks. Yeah, and then I'm going to remember our old friend debug log outputs things to the console. So what do you think is going to happen? So always, once it's error free, you have no more red squiggly lines. Try to visualize in your head what the code's going to do. You pop over into Unity. You see my score is 0 here in the script on my game object. I hit play. And did you expect this? And if I hit spacebar, see the number changes to 1. You can also see the score incrementing over here on the right hand side in the inspector. And if I mash the spacebar, up it goes. So when it was spamming out all those debug log messages, right? Were you expecting that? Or were you expecting it only to appear once, right? Well, here it is in the update loop. And if the key was pressed, it does this step. But after it's done, it always does the debug log. So we might want to move this. We might want to move that up into the if statement. And now it will only show you the score if the score increments. So let's just give that a try. Boop, 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 boop. See, not spamming anything. And if I hit spacebar, there's my 1, 2, 3. Nice. Much cleaner, right? But hey, we're here to make a game, not make a spacebar number incrementer. So what do games need? Games need pressure. So let's make a float because let's see, let's call it time limit. So time in Unity is measured in units of 1 equals 1 second. So because the game's running faster than 1 frame per second, right, probably 60 frames a second or whatever, we need a float to keep track of how many seconds have gone by, because fractions of seconds will go by over time. So let's clean this up a little bit. So I'm going to make a void function called increment score. And increment score is going to handle this. So now I have one nice little spot where now you see my update loop is much more readable. If the key was pressed, increment the score. Easy. But whether the key was pressed or not, doesn't matter. I want to, you know what, this is a bad name, time left. I want to decrease the amount of time left, which I'm also going to turn into a function. Sometimes I'll just write the function name and then I'll make the function later, and then the red squiggly will remind me. So let's make a function that decreases the time left, which is really easy. We're just going to say time left equals time left minus. Did I cover time delta time this morning? Maybe I did. Maybe I didn't. Time is a class. If you mouse over it, you can see it's built into Unity. So this is a Unity feature, a C# feature. And delta time specifically is the number of seconds between or since the code last ran. And because it's running at 60 frames per second or higher, that number, delta time, is going to be a small fraction of a second. But the time is going to tick down in a nice rate over time, right? I could have also said time left minus equals time to delta time, which is the same thing. Another way of writing the same thing, right? So now the time is going to decrease no matter what. And if we open up Unity and just test that out, sure enough, our time left value is just whittling away into the negatives. Why is it whittling into the negatives? Well, if we stop, we didn't tell it how long we have to get a score. And we can just type that in here, right? We just started out. So you have 20 seconds. And now if you hit play, it'll just start decreasing this value. See, 19, 18, 17, boom. There we go. Now we have a nice countdown timer. So what are we going to do with this countdown timer? Well, we need a goal. What are we trying to get to, right? We could just say, how many scores can you get in 20 seconds? Sure, but it's more fun to have a goal. So let's make a goal. Now, when you increment the score, if the score is greater than or equal to the goal, you win the game. Otherwise, if you haven't won the game, we just output what your current score is. Nice and simple. If we wanted to learn a lesson from before, right, spell out your logic. So you just move that logic there. Now it reads better, more English. If you did win, right, win. If you didn't win, then we just output your score. But once the timer runs out, you can't win. So we haven't accounted for that. We just have a counter ticking down, no one cares. So we need to check the timer to see if you've won or not. So let's say here in the update loop, we don't want the game to continue if the timer is up. So is timer, if the timer is up, or if out of time. Out of time. So what defines out of time? Out of time is when time left is less than or equal to 0. Then we could say if you're out of time. What do we do if you're out of time? I'll do this. Lose. And forgot the semicolon. Let's see. Return. So if you remember, return just goes back to what it was doing. So the update loop will get this far and then it'll just stop and it won't do any of this stuff. So once you're out of time, we will no longer decrease the time and we will no longer even check if you're hitting the spacebar anymore, right? It'll just going to stop here. Now another way of writing this is we could say else, and then we could put the else way down here. See, it kind of auto formatted it for me. See how this logic kind of flows the same way, right? So the downside, it doesn't matter whichever way you want to do it, and there's lots of ways to do this particular logic switch. You know, did you lose? Did you win? But this way is a little bit less readable because now you have to hold in your head that there's kind of this nested if statement, right? And it's easy to get confused, and it's easy, especially if your code gets really, really long and you've scrolled down off screen and you're just staring at this like this. It's really easy to forget what got you here in the first place. And it might not be working the way you think. So I'm going to just hit undo here. I actually prefer this because it's really like it keeps the level of nesting one step down. There's less indents to deal with. And it's really clear that this just ends execution right here, right? Like this return is just going to stop running at all. So why don't we give this a test and see how it works? And I know there's bugs in it, so let's fix them. First, I'm going to hit spacebar. Oops. Win. Was that expected? Yes, because I never set the goal. Let's set the goal to, let's make it, just for testing, let's make the goal 3 so that we get there nice and quick and we can iterate faster. Right, 1, 2, win. Nice. And every time I hit spacebar, it keeps winning. So there's one bug. The bug is we can win multiple times as long as there's time left on the clock. You see as the time is counting down here, we're just hitting 0 and boom, now we're spamming lose to the console. So this is why rapid iteration and trying out your work as early as possible is important, because then you can get to these little issues really quickly and start solving them. So first bug, we only want to win once, right? So how do we solve that? Well, we have a switch here. If you're out of time, lose. If you already won, we know you've already won. If your score is greater than or equal to your goal. Score is greater than or equal to goal. If already won. Actually, we want to invert this because, oh, no, we don't. Nope, this is right. Okay, there we go. So if we've already won, we don't want to spam anything. We don't want to say you've won because we do that elsewhere. We just want to stop executing, right? So we just return. So now we can't win more than once. That's good. But we still have the problem of the lose is spamming all the time. So that one we're going to fix here in decrease time left. So similarly, we say win here in the increment score function we made. Why don't we add the lose thing in a similar way to the decrease time left function? Now we don't want it to say lose every time it decreases time. We only want to lose if time left is less than 0. There we go. So Yeah. Okay. So now in the update loop, it's first going to check if you're out of time. If it is, it doesn't do anything. And it's going to check if you've already won. If you have, it doesn't do anything. Otherwise, if you make it here, you have time left on the clock, and you haven't won. Both those things are true at this point in the code. Now, you check if the key was pressed, increment the score, and then decrease the amount of time you have remaining. Right? Nice, easy. That should be all of our bugs fixed. Our code's not perfect, but let's give this a try anyway. You know what, you can even edit these numbers live while Unity's counting down. I'm going to change the time limit to 10 seconds. Let's try 1, 2, 3. We win. And look at that. The countdown timer stopped running. Perfect. And you know what? Instead of just saying win, well, we add a competitive element. So let's say points. What's points? Points. Okay, so whoops. There we go. Okay, so now I'm gonna make it so that when you win, it's gonna tell you how many points you got. What determines the number of points you have? Well, let's say right now it's 0. Let's change that. Let's make your points equal to your score times the amount of time left on the clock times 30. Sure, there we go. If you want to get fancy as well, there's another keyword. There's a math keyword that does all the kind of things that you want to do, um, like rounding and stuff like that. So I'm just going to use the math function to round this so we get a nice even number. It'll be a nice big number like pinball points, you know? And then depending on how fast you do it, how fast you get your score, the more points you get. Nice, easy. Now because the score is kind of, your score will always equal to goal. So maybe there's room to play around with that later, but now we get some points. Let's, oh, did I save? Let's hit play. Let's see how many points I get. So depending on how fast I go, I got 1,569 points. Good. Now, I mean, we're already at a point where we could share this out as a fun game, challenge our friends and things like that. So logically, the game is sort of complete. There's a few things we can do to make it a little bit better. Now, remember what I said earlier. You never want to repeat yourself twice in your code, right? Did you spot the repeat? It really bugged me when I did it, and I was like, oh, this is biting my tongue. But it's right here on the screen. Can you spot it before I explain it? It's the out of time calculation. And similarly, we calculate did win in the same way. Did win and already won are actually the same calculation. But this one's on the same screen, so it's nice and easy. So we have out of time defined in 2 places, and both of them are defined identically. This is annoying that you had to type it twice, first of all. Second of all, it's a potential bug for your future self. So imagine way down the road, you're like, oh, you know what? We want to give you like 3 seconds of leeway, so we're going to make it -3. You don't actually lose until the timer's at -3, right? Well, now I've changed it here, but not here, and now we're going to get differing results in the code, right? Depending on what's calling it. So what we need to do is combine them into one single function call, which is nice and easy. Just a nice reference function. You can say bool, because it's going to return true or false, is out of time. Braces we always need. And we have the logic right here. Actually, I'm going to return it back to 0. There we go. Now we have one central function that tells you if you're out of time or not. I'm just going to copy this. I'm going to delete this. Now we can just say if is out of time. And likewise, down here, we can delete this. And we delete this, is out of time. There we go. Now, instead of defining it separately in two different places, now we have one central spot. And now if we change this to -3, then both this function and this function are both going to have the same result because they're both calling from the same source, right? And especially when you start getting really complex, really deep nested, really long code, you really want to start using these functions for just about everything, right? And you do the same thing for bool has 1. We could say return score is greater than or equal to goal. And then we can just say has 1. And then you can copy that. And we delete that. And we got to change it up here as well. This one here, we don't need that. Has 1. There we go. Look, nice and neat. And I think it becomes a little bit easier to read as well. And I mean, maybe you're reading through the code and you're like, increment score, if has 1, what is has 1? There's a shortcut. You hold down the control key on your keyboard, and when you mouse over a function, it turns blue, and if you click on it, it takes you to where it's defined. So you can start zipping around your code really quick just by holding control and clicking, and to figure out what defines this, what makes this true, right? And if I want other scripts in the project to be able to tell if the game's over or not, remember, we just make it public. And now anything in the whole project can tell if the game is over or not just by calling this one function here. By default, it's private, so only this file can use it, which is fine for our needs for now, so I'll just leave it like that, right? So now I haven't changed any logic. I've just changed how readable it is. And you think this update loop now, which everything on this screen, this is the only function that Unity calls, right? Unity says update. Every tick, every frame per second you have just calls update. And now, perfectly readable, we can see if you're out of time, do nothing. If you've won, do nothing. There's time on the clock, you haven't won. If you've pressed a key, increment the score, decrease the amount of time left. Easy, right? Easy peasy. The victory condition is handled in the increment score, so you only check it when necessary. The lose condition's only checked when you decrease time. If you want to check on that, hold down control, left click. There we go. If you want to get a little bit, just a little taste fancier, why don't we make a public string that says win message? Make that lowercase just for fun. Instead of saying win your points, you say win message. And then if you want to say public string lose message, instead of saying lose, we'll say lose message. Now, what is win message and what is lose message? Well, because I made them public, fully scoped variables, you'll see it here. There we go. So now here in Unity, we have all the controls for the entire game, right? We can define how much time you have. We can define how much, what score you start at, which is 0. How many points you need to get, what to say when you win, what to say when you lose. And now you can share this game with any of your teammates or any of your friends, and everyone will see your, whoops, I double clicked. Everyone will see your custom winning message here in the log, done fully customizable. Now, those win messages and lose messages, those can be game objects or animations or all sorts of like 3D boop-a-doo-ba-doos. We can make it super exciting now that we've publicly exposed all the handles and levers for our fun little game. That's going to be next lesson. The next thing we're going to do, the next project we're going to do here at Old Man and the Sea, is we're going to make all of this 3D. But the reason I wanted to walk through this is because, first of all, I mean, look at this. I'm at almost 100 lines of code. And at the beginning of this lesson, if you walked in and you saw this on the screen, it would probably be intimidating if you've never really dug into code before and you can't understand it, or you don't understand it. Not can't. You can't right now understand it. But if you zoom in, it can feel really overwhelming. Like, just what is all of these things? But we just walked through it, right? And I made it as simple and as plain English as possible. Code can always look this simple. Code can always look this good. The only time code gets more complex than this is when people are taking shortcuts. And you'll find when you get better at programming, you're going to start actually putting all those nested parentheses into the if statements, and you're going to make it long, and it's going to be obvious to you, and you're going to start taking shortcuts. That's fine. It's your code. You do what you want with it. But if you want the ultimate in readability, you lay it out like this. And the bonus is, if I ever go and make a new game, if I ever go and make like I want to make a completely new game, I have all these nicely encapsulated little chunks of code. And I can just, you know what? If I ever want a timer, cut and paste this right here. I have a timer in any game now, right? And it's fully customizable with a custom lose message. We already know is out of time, already compares against 0. Like this whole chunk of code right here, it'll work as a timer in anything. You only have to write it once in your entire career. Now you might think of ways to make it better, to improve it, but you only have to improve it in one spot, and then all of your projects from there on going forward get better. And that's why writing code in kind of this nice, simple, easily readable way makes everything really easy to maintain, less bugs, easier to logic out in your brain, easier to figure out. And now I've broken down the game into discrete tasks. I've made a good sandwich. I know this game is being played here in the console log in Unity. It has a win, it has a lose state, it has a high score. It's the definition of a game. But it still is only played in the console output of Unity. You can't really compile this and send it to a friend. You can only send the source code to a friend and they can run it in Unity as well. So that's next. So what I want you to do is think about what you might want to make, or just try to recreate this. Just try to, from memory, try to recreate this and only reference the video if you need to. If you can make this, you're doing better than most people on the planet. What, like one in 100 people can code, right? Doing that, super simple. Next lesson, we'll teach you all about the complexities of Unity and how to make it all 3D and fancy and feel like a real game. But you always have to get the logic working first. And honestly, this is how I code. I will make my console say win or lose, and I'll get all the logic done, I'll get all the bugs solved, and then once it's ready, then I'll expose things kind of the same way I exposed this win statement. I'll expose that to the artists or the designers or the writers of the team. All your other teammates can then go in and easily just, you know what, instead of WinR, let's just swap that out for some fancy particle effect. And it's really easy for your teammates to do that, right? So once you get the logic solved, the rest just kind of flows naturally. So that's what this lesson's about, just the flow of logic. What tools you have available, how you can compare them and manipulate them. Right? Nice, easy, but it's 4 o'clock. There's still some sun up in the sky. Why don't we head back down to the lake? We'll go check out the boathouse. I hear there's a motor canoe in there. It's got 3 propellers. And yeah, we'll come back. We'll reconvene. Let's say after dinner. Good job, everyone. Remember, this would all be much easier if I remember where my stop button is. I switched software, so what is it?